A large crane is being used to lower a 10,000 kilogram storage unit into place on a barge. So 10,000 kilogram is the mass that is hanging from a crane. So I'm going to call it mass of the object. If the cable that supports from the end of the crane is 12-meter long, so this is the length of the cord, and the linear mass density of the cable is 1.78 kilogram per meter, which is the mu. How long does it take? So it is talking about the time. Take a wave to travel a length of a cable. So let's pull out the information in a table format. So we have mass of the object equals 10,000 kilogram. We have the length of the cable 12 meters. We have the mu, linear mass density is 1.78 kilograms per meter. And we want to find out the time it takes for the wave to travel along the cable. So if we try to picture the situation, so here's our crane. Suppose this is the crane. Okay, so and then we have the cable, and there is an object that is hanging from this cable. So the wave is gonna go up, or wave is going to pass along the cable that has a length L, and this is mass of the object. So when the wave passes through along the length, the time it takes, we know it will be time equals length over the speed of the wave. So how do we find the speed of the wave? Well, we know the length, and to find the speed of the wave, we know that it depends on the tension of the cable, force of tension, divided by the linear mass density of the cable. Now, how do we find the force of the tension? Now, the question is that, for that, let's draw free body diagram for our object. So this would be MOG, the weight of the object that will provide the tension in the cord. And then because everything is in equilibrium, I can say that tension, let's just use a force of tension Ft, because remember our capital T is occupied for the period for a wave. So force of tension, because if our object is in equilibrium, I can say force of tension equals MOG. Okay, so all I need to do, plug this into my equation of the V, and then I can have it equals square root of MOG over the mu. It seems like I have everything in here. I can plug this expression into the expression of time above here, and then I can find the time. So let's just rewrite our expression. Time equals length over the square root of MOG over mu, which also equals L times square root of mu over MOG. So let's plug in the numbers. That equals, well, 12 meters for the length times square root of 1.7 kilograms per meter over 10,000 kilograms times 9.8 meters per second square. Okay, so let's prolong this one and punch this into your calculator. You will get equals 0.051 seconds. Thank you for watching.